The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello, everyone, and welcome. My name is Nathan, otherwise known as Old Man Builds. What's going on, guys? Getting ready to rock out some little RAVs, man. I've been working. Right on. Real quick, I just want to give everybody a quick update. Worked on this thing right here. We're going to try to rotate the, sorry, feel all jumbled right now. We're going to try to rotate this, which is cool. I'm just going to use my wire winder to rotate it. But I came up with this, and it puts in my number one coil into it. And when you get it there, we'll have just enough room to rotate this thing perfectly. And then it'll be able to turn on. So we'll be able to take care of that. So I built the S-tail for that. We're going to be able to put the number one in there. It's going to look pretty cool, man. That's going to be awesome for that project. And then I set up a little area so I could do the RAVs. So I wanted to show you guys that real quick. Man, there's a lot of cool stuff. Man, these things are bright. Like, it's like looking into a laser beam, to be very honest with you. It's it's insane. I don't know how many people saw the video yet, but I put it up of just testing. I didn't even say anything in it. I just figured we'd check it out. Yeah, this thing's gonna work good, man. This thing is gonna work good because I thought about it, and there's like two more parts that go on the end, and then we're good. And then that one's rolling. So I'm just waiting for a piece of nylon that comes in that's threaded. It should be an M4 thread. So that's what I'm waiting on. As soon as it gets here, man, then I'll be able to run this thing. Nice. Man, you got some cool stuff. RAV's looking better than ever. Let's take a look. Let's see what the old man got this time. Not very good at it. Like I said, Sean's the expert, but let's see if I can't give it a try. Look at that. So what you're looking at right here is the RAV. I actually built it, and I got it to work, and it's so bright. What's going on here is my frequency is too low, which means my amps are too high. You got to remember, it's all driven by a DC pulse. So what I need to do is I need to change my frequency. So either I change the capacitors, which I could do on the ZVS, not a problem. I could also go in and just add a frequency circuit to it with a trigger circuit, and I can add frequency to it. I think the first thing that I'm going to do is take my ZVS with my cap bank, and I'm going to change the capacitance in it, and I'm going to make the frequency go up. I'm 11 kilohertz short of what Sean has. So I'm at 89 kilohertz. Sean is at 100 kilohertz. So you could see the difference. Mine's brighter. It shoots out everywhere. You get a good look, man. It's like looking at a sun sometimes when you're doing this. Right on, brother. Yeah, it's a good size. So we're doing good. Yeah, let's take a look at the next one, man. These things are pretty cool. Yeah, you can see all the color in there. It's starting to shoot out. Mostly white, but we got some color. If you look on the upper right, there's a little portion right there where we're building something in. It's right up here. I'll put my cursor on it over. You can see that right there. These things are like shooting lasers out, man. So basically, what a RAV is we're looking at something that is like ball lightning or like a plasmoid, but not exactly just yet can be classified as that. So Sean calls it a RAV. So we just, yeah, controlling the current's not that hard. It's a DC system. So as soon as I change the frequency up a little higher, the amount of current will go down. So the amount of amps will go down, the amount of voltage will go up, which will mean I won't have so much spraying light, and then I can attenuate that down just a little bit and get it so where we can see a high level of detail inside this thing. And then we know the level that we'd have to bring it up to get this thing bigger. So we're starting to work it out. Yeah, you can see how bright this sucker is. You can't look into these things. Let's see if we got one with some color in it. There we go. You can see right here. We have that little colored thing in the back, the fourth dimensional thing Joe talks about. It's right there. I took the pictures real close as I could, man. It's not as nice looking as Sean's yet because the amperage is way too high. I'm getting blinded out by the yellow that's going on here. Yeah, that reflection, man. I'll have to show that in a little bit. Yeah, Earth is a battery. That's correct. I agree with you. Nice. Right on. Yeah, you could do it in the beam version as well. Absolutely. You can see it. We're still hitting it right behind it. You can't see it as well because, like I said, we're too bright. Let me see what we got. This one's cool. You're just starting to see that little guy form, but we already have this right here off to the left. So I just did these this morning, guys. I just busted this out this morning. Right on. We'll take a look at that. Yeah, I'm going to get through all these first. Thank you, Crypto. Appreciate it, man. Yeah, hit that like button, man. Make sure this gets pushed out everywhere. Yeah, no, man. We did this today. Creating this stuff. I'm going to get real good at this really fast, just so you understand that. Yeah, you can still see it. It's like pure white. But over here we still have our dimensional objects right here. That's cool. There it is again. Take a look at this one. On the upper right, you'll see it's red. Right up here. There's a red mark. These things are shooting out like lasers almost. Oh yeah, we'll get to the videos in this, man. They're pretty awesome, man. It tells a story. There is no ring magnet in this, guys. This is a simple pan with clay, no magnet at all. Let's see. Yeah, and that's pretty looking. Look at that. That's absolutely amazing, man. It's a small piece of clay. Very small. The things are hard to look at, man. Blind you, give you little black spots in your eyes for a while. I'll show you guys the setup here. There it is. That's my old man builds junkyard style setup. I just taped a bunch of stuff to a piece of PVC pipe. I guess knowing what you're doing is more important than how it looks. Sean did not agree. So I'll have to fix that. But this is just the power source that I was breaking down on what Sean had. And it's an AC flyback. So I just took my AC flyback right here. I took a ZVS and I ran this thing, man, and came out with some beautiful pictures of this stuff. That kind of goes to show you, man, it's more important that you know what you're doing. The rods right there are stainless steel. The pan is aluminum. It causes a problem in the fact that you saw the bright light. It changes what's going on in there. So Sean has stainless pan with a stainless tip, and it'll change that as well. So just understand that we got a little bit of difference here. And like I said, Sean's frequency is 11 kilohertz higher, so he gets less amps, so it's less bright as well in that regard too. But you can see how small the piece of clay is. It doesn't have to be very big at all. Yeah, it's just a pie tin. Something you get your apple pie in. You know what I mean? Yeah, I did MacGyver it. I'm like the fat MacGyver. Oh, that's hilarious. Yeah, I don't care what you call the flare, man. I'll be very honest with you. I care about what's going on in that little RAV. That's what I care about. Try it in the open air. Well, you got to get the anode cathode effect just right. But yes, I've been moving the my little piece of PVC pipe up and down when I was doing some of the testing, and I think I can pull it a bit more distance, but it likes to stay next to the clay. Yeah, there's barely any water in that pan. Well, in this one, there's a little bit more water, but that's not what the reaction necessarily is. I'm finding some different things. Let's see what else we got in here. Yeah, it's like looking at the sun sometimes, man. I got black spots in my eyes looking at this thing. And it starts back up too, by the way. You can start it right back up. It didn't even go in the purple phase this time. Yeah, we'll play that one again, man. That was really cool. That's a cool trick. I'm gonna try that, Dennis. I tried to adjust the zoom in to get a better look, and it just makes the picture crappier. Okay. So I got those, and then let me find the other ones I have real quick. So mine didn't start right away. This is one of the first attempts I did, and it didn't start right away. A motorcycle going by, apparently. There you go. It formed up. This camera doesn't show it like the other one. You see me, I'm pulling it away. I want to see how far I can move that anode from it and so continue the reaction. So I moved it at least 5 to 6 millimeters. Sorry. I'm reading everything. So was that one? I had a trouble with the thinner cathode and the wrong setup before. So on this piece of clay, there's some like marks that are cut right into this thing. Well, for this, I'm just using an AC flyback. That's all it was for the standard ZVS. I'll go back and show you the circuit here in a little bit. But I got this thing way too hot. Way too hot. Well, I need to just put my adjustable cap back in here with my high frequency caps, and I'll be fine. Now this tip is the best one. Trust me. It's not the tip's fault. It's my fault. I'm messing it up right here for sure. I don't know. Look at that. Yeah, I don't think it's quite there yet, but it's getting there. It's way too hot. You can see the yellow in it. I shouldn't have that much yellow in there. I'm like, God, I probably need to drop it down by an amp at least. Way too hot. Yeah, you can see it's just too hot. There's not enough purple in there. There's too much yellow. Again, you got to remember this is probably the first successful RAV that I built. So we're just starting at this. Not where Sean is yet. All right, there's the one last one, and then that's it. We'll talk about other stuff, I guess. What's that one? Yeah, I think this one's very short. No. Okay, well, let me pull it up. All right, I'll just show this one last picture, and then I'll go on. Joe sent me something. We'll take a look at it. Take a look at that. So check this out. This is all the lights in the rainbow coming out, shooting out of this thing at every angle. It's got everything. It was one of the best pictures that I got out of this thing, man. It was really cool. Yeah, that's why I say it shoots out like lasers, man. It really it's showing it going everywhere. There's a lot more to this thing than we think. All right. Let's see what Joe sent me over here. Okay. Now this is Sean's RAV right here. See, he got way better than me. You see the already. You see the. Well, that was cool. Hold on. Let me just pause this for real quick. Yeah, you can already see the difference in it. So hang on, I'm going to change this real quick.
Holy fuck.
Okay, didn't want that on there. Hmm. Yeah, that little thing's just going everywhere, isn't it? Yeah, thanks, Joe. Hmm. Hmm.
All right, let's check out the end. Oh, we don't have the end of it, do we? Oh, we do have the end sequence. Okay. Now look, it's coming back because the orb's coming back into frame. So there's something to do with the relative nature of the lens and the flare. Oh, All right, well, I guess we didn't have the end of the reaction to see if it reabsorbs. And it hits the rim, and you could actually see it changes its entire geometry. Is moving, but look at what this thing does. And look, it curls around. Zip, it changes its entire geometry, zips off with a point at a leading edge. And then it hits the rim, and you could actually see it ride the rim, zip off the rim, and then double back the way it came. Watch this. Right there. It's on the rim, rides the rim, off the rim, it's to the left, to the right, and off. It goes to the right, it goes to the left, and zips off to the right. What in the world? All right, let's check out the end. Oh, we don't have the end of it, do we? Oh, we do have the end sequence. Okay. Now look. All right, well, I guess we didn't have the end of the reaction.
All right. So just cool stuff, man. Yeah, I was looking at it today, man, and stuff kind of moves around when you move the camera, so keeping it still is good. I think really one of the things we have to look at in that whole thing, man, is just drop the amount of amps in this thing and let's see what it's showing us. That's probably the best way to do this. You know, shaky camera, playing around, set up a tripod, man, just put it on it, change the amp, see what we get. Yeah, very very funny, Brendan. By the way, nice work on your building there. Saw it on Facebook. Very nice. Yeah. Well, now that we know what we're doing, I mean, you gotta understand we're just starting with this whole process. Sean came out with it like what 2 weeks ago, I think, maybe a week, probably 2 weeks. And then now we're trying to catch up to them. We're building one on our own and seeing what we get. That you guys saw my first attempt today. We got some information. We got to get a lot more. See exactly what's going on with the what's in the clay, what's not in the clay. Is there anything else that can start this up and hold it right there besides the clay? Sean tried the granite, didn't work. We'll try other things. The clay also might be different that he's using than what I'm using. So I noticed the inside of mine was kind of black, and I didn't see that in his really. And that may change things as well. And then I'm obviously in a completely different setup. Let me find that picture for you real quick on the setup itself, because it kind of tells a story of what's going on. Let's see, where do I have that? In that one? No, it was in the other one. Okay. So there's my junk setup for mine. So you can all see it's just an AC flyback. You see the two wires coming out of it. So it's AC. Doesn't have all the pins. All the pins are only on DC. A simple, what is that? like an 850 watt ZVS or a 1000 watt ZVS, the cheaper version. And we have a stainless steel anode and aluminum pie tin. And that's it, just a piece of clay right there from a pot and some water. But it's making some nice, cool stuff, man. By the way, those AC flybacks right there are totally awesome. Totally worth the price. You can find them on eBay. But what I'm going to do is take the ZVS I'm running there and go to my ZVS that I use on my Tesla coil. Because it has an adjustable cap bank to it, I'm going to adjust the capacitance in it in order to adjust the frequency on this thing because it's DC. It'll make it real easy. Just flip the switch, man, and we should be able to change the frequency right on. And then I can lean out the amps and I can bring up the frequency in it. And we'll see a whole different RAV as soon as I'm done. But then on the opposite side, when we have it bigger, we can then start changing the capacitance as we want and see what it does. So that's kind of one of the reasons to do this. So, yeah, we're getting some different looks at it, man. You know, right off the bat, we got one. Sean says it took him a little while to get his first one. And I set this up and, 20 minutes later, I got one only because he did all the legwork first. And I came along after that and he told me exactly how to do it. So, but he learned it the hard way. So congrats to Sean, man. He's doing a great job on this. So, yeah, we got that going, man. Cool experiment. I think once we remove some of the amps out of this thing, it'll get rid of the thought process on any kind of slag or anything like that. And I say that because these things run on frequency, man. The amps and voltage are just there to move the frequency. And I can tell you that right now because I was at 15 volts on my power source and I dropped it down to 9 volts. And it still made a beautiful RAV. So the amps and the voltage not so much important. The frequency is massively important. So yeah, I was at 89 kilohertz. Sean is at 100 kilohertz. So we'll just have to work on that just a little bit. The cool thing was when you push things to the limit, man, you see exactly how far things go. So yeah, it's pretty neat. Yeah, you get across an LED. Yeah. Yeah. Just remember, this is all in open air. We're not confined inside of any glass bulb or anything like that. So the reaction is slightly different than what it would be inside of a vacuum bulb. I mean, when you really think about it, they still got an anode cathode relationship. One's in a vacuum, one's not. So this is an open air. So it builds out a little bit differently than it would in a vacuum. So same kind of process going on though. Yeah. Well, you got to mention it, man, because a lot of people get confused. They go, I got the effect that I call that, so-and-so. And then you go, why are you calling yours this? They're the same effect. There's no difference whatsoever in them, except for the fact that, you can find one inside of a glass tube. That's really the difference. You still got an anode cathode effect. You're still dealing with the frequency. You're still having to balance it both in resonance on both sides. It's as simple as it gets. So, yeah, we need to increase the frequency. You're absolutely right. Because the frequency, you can see the difference. Okay, so if you understand high voltage, you'll understand this. The more purple it is, the more voltage you have, the less amps. The more white it is, the more amps you have, the lower the frequency, the lower the voltage. So if you keep that in mind here, when you see Sean's, it's a cleaner look because there's less amperage in it. There's a lower there's less amperage in it, there's a higher frequency in it. And that was proven true by looking at the oscilloscope, and he's at 100 kilohertz where I'm at 80 something kilohertz. So not really a problem. We can fix that. That's real simple. Just a couple of clips on a cap bank. We go from slow switching caps to a fast switching cap. We click a couple, change capacitance, boom, we're there. We'll hit that 100 kilohertz, no problem. And the good thing is we'll be able to switch it while it's on. So mine lasted 3 minutes the entire time, and then my ZVS gave out, and it had no fans on it, so my fault. There goes another $20. So I got another one. Trust me, we'll just keep switching them out, man. I don't care what I blow up. I'm going to get the answer I want. But the cool thing is some of the effects that go on with the higher voltages, and one of the reasons I wanted to leave it on, because I want to split the anode and make 2 of them. And Sean, being the awesome, cool guy that he is, sent me this little thing, and he's sending it to me in the mail with those little helping hands that, just clips so they can hold stuff, man. Sean, take care of me, brother. He's got one of those things coming in so that I can do it on both sides now, get 2 setups going, because I want 2 RAVs at once. I want to see if I can get them to connect at all. If I can get them to connect, I can pull an Einstein-Rosen bridge out of them. That's the thought process. Can I get it to connect and do that? Can I get it to match his? Okay, that's what I need to do first. I need to match his Evo, which I'm real close to it. Okay, then can I do a second one right next to it using the same relationship so the frequency is exactly the same? Then can I get it to combine together? Okay, it might just blow up in my face. Who knows? But you got to try. So old man's going to give it a shot, see what I could do here. But I think it's going to be totally awesome and epic if it happens, man. Because we were looking at the water and the vortexes in water and how they combine together. They have the same frequency and relationship as they go into the vortex. It's exactly the same. So we looked at it and said, okay, well, we're dealing with the same thing here, except for we're in a sphere. We're going to change the geometry to a vortex. For those of you who don't understand this, changing geometries is going to happen with voltage all day long. All day. As soon as I change the configuration, man, we change the geometry, boom, it's going to change the reaction. So, yeah, it's going to be awesome. Yeah, of course, we're going to fry it and find out. Man, I fry a lot of stuff. Let me just tell you that. ZVSs are a dime a dozen to me, man. I fry a lot of this stuff. And then I find out, where the limits are and then stay within those limits. But I have no problem frying something to the ground. As long as it gives us a decent result. Yeah, prepare for the arc flash. So I ordered some laser glasses because this is not something that can be done with a welding mask. This is more like high-powered lasers when they come out. I could tell you the reaction in my eyeballs. We're getting a ton of stuff like a laser, okay? So my eyes got black spots in them from just looking at this thing. But there's every color of the rainbow in every single thing that comes out of it. It's intense. So what you see on the screen, just imagine staring at the sun for about 20 minutes, right? That's the feeling you get. That's what's going on here. So, yeah. Yeah, the laser, I think the laser thing is the way to go. I don't think the welding goggles. And it shows out in the test. You see all the beams coming out of this thing? And as soon as you saw the beams coming out of this thing and you see the reflection in the pan, that you got like a laser color, you kind of know it's a laser. So, do I have a high-speed camera? I have a ZV-E10, and the lens on it's a kit lens. And I'm looking into they have an adapter for $100 that works real well. And they could put Canon lenses on them. So I could pick up, for half the price for a Sony lens, I can pick up a Canon lens and get double the distance out of it. You know what I mean? So that's what I need to do. This thing is beautiful in the dark. Okay. And it doesn't have a problem whatsoever with the sensor, and it's great in the dark. It's the camera's tuned in. You saw the pictures from it on one of the last videos that I showed. All the wide angle shots are done from my Sony. And then all the, cut up shots like this is all from my cell phone. So, yeah, you kind of get different views of it, different angles, different things that happen with the camera themselves. So, Yeah, I need to get that lens, man, so I could zoom in at a distance so I don't ruin my camera. Because I literally have it maybe this far from the RAV itself, which is just bad for the camera. Yeah, you know what? One thing I would like to do, if I can find it, is I want to get, oh, how do I want to say it? Like little strips of mirror that are broken, like the disco ball is, just a little bit, so that I can wrap them behind this thing, or maybe even bigger ones. I want to see what's angled at the reflection when we see it. I don't know if that makes sense to a lot of people, but when you're dealing with lights, you got to see the dark spots and the light spots, and you got to see what's going on behind things. It doesn't always give you the full picture, but if you're getting the front, back, and all the sides, now you have a better chance. So, yeah, I'm gonna try that. Just put up some mirrors and see what we get, and then maybe we'll take one of those ones that are like a zoom mirror. You know what I mean? That I go steal it out of the wife's bathroom. You know what I mean? One of those little zoom mirrors they do for plucking all their hairs. I get one of those, man, and put it on there. Maybe the zoom in on it will help. Oh man. Yeah, we'll have to give that a shot. I mean, everything's worth a shot, man. Give it a shot. But I got the same cathode and anode as, excuse me, same anode as Sean. He sent me which one to get, and I ordered them. There's a big pack of these things. So I only got into two of them so far, a real thin one and then a pretty thick one. So use the mirror as a crystal. No, I'm just trying to use the mirror to see what's going on behind it. That's it. I just wanted to get rid of, you know what I mean, any unwanted light or anything, reflections, anything I can get out of it would be nice. Yeah, just surface interactions, things like that. Because once we lower the amps in this thing, man, you'll be able to look at this thing. That's the problem. It's way too much amps, too much white. Yeah, reveal interference patterns. There you go. See, we're all on the same page. Yeah, I think it's definitely worth a try. We'll give that a shot. I'll go steal the wife's over here after I'm done. I go to give it a shot afterward. Um, you do the LED lights to lower the frequency. Well, yeah. Well, the changing the capacitance will lower the frequency as well, or raise the frequency. And I want to lower it. I don't want to lower the frequency because in a DC system, as soon as you lower the frequency, the amps go up, and I've already got enough amps. There's too much white. Yeah. You say no, the LED increases the frequency? Well, cool. Kills off some of the heat, takes away the amperage. Yeah, that sounds about right. I just do it with a cat bank. I'm very honest with you, man. I'll just do it with a cat bank. I also have another thing where I could just hook up my frequency generator to a trigger switch, put it through the power source. It'll take the ZBS and allow me to put whatever frequency I want into it. So if I really want to go, up a couple hundred megahertz or kilohertz, I should say, if I want to get to 1 megahertz on it, I can do it right through the frequency generator. No problem. I've used that circuit for everything, man. You can put it on square wave spin magnets inside of any coil you got. You can put it on this, man, change the frequency or flyback. I've done it a bunch. It all works. You just gotta figure it out. Yeah, the LC tank circuit style tuning. Yeah, it's not that difficult. As long as you realize you're in a DC system and not change it, you're good to go. Cat bank, CAP, not cat bank. Sorry. Yeah, it sucked for my cats. No, thank you. Yeah, we just push frequency right into the base. Anytime you push it into the base, you can change the frequency of something using your either a MOSFET or a transistor. Yeah. Sorry, man. Yeah, it's my dentures. I have certain words come out funny. So sorry about that. Yeah. No, these things are pretty cool, man. We got that going. We got the other one going. I'm gonna throw that primary into this into this thing right here when I do the other one. Let's see if I have a primary. I'm sitting over here. The primary itself, man, is winding of like 12 gauge wall wire is what it is, and it's just wrapped a certain way. So it sits inside of here. So the distance is perfect every time it goes in there. And they come out here, and I got to put a hole right through here and run it through the back side. So now when I change the angle, just understand it's going to sit like this. And that's going to sit right there. And it's just going to spin inside here. So, yeah, we'll be able to flip the angle on this, no problem. I think that's the way to go, man. When you get it to rotate, we'll go slow at first, but then we'll get it to go. Yeah, that's going to be awesome, man. I've been working on that one too. I've been in STL hell, if that makes any sense. I've been in the CAD program working on things one after the other because there's other stuff I got going on. So over here, I got some, let me say this, some needles for my Tesla coils that I wanted to add for a feature to everybody who wants to purchase a Tesla coil. This is the one that they sell for it, and it's fairly small. Okay. This is probably close to 2.5 inches, is about what it is. The actual threads on it suck. So I had to get an adapter to get it to go bigger because when you solder on one of these thread inserts that goes in for these things right here, the smaller, the worse it gets because solder gets put into everything. But one of these is awesome for it to make a breakout for the Tesla coil itself. So those are there. I also got, and I found adjustable ones. Well, not adjustable, but I mean, there's like 5 different sizes in here. So they have the long one, then shorter, shorter, and shorter in case you wanted to do any of that. I got those so I can add to that kit. And then I bought a bunch of quick connects. So now the wire number 2 that comes out, I'll make a little thing in there so you can quick connect it, change the top off. You could do the one wire energy, or you could put the needles on there and get the sparking for the voltage for those who want to do AC out of this thing. Yeah, it'll just be precise. And then once I get it all together and build it, I'll do a build video on it. And then I'll put all the stuff in the description of it of exactly what I use. So if you want to purchase it yourself, you could do it. I'll put it up on my shop in case somebody wants to purchase this there. Also, I have 2 other things coming out. Grounding cable. So what I did was I bought a bunch of little shells for the 3-pin plugins, and then bought some wire that's 2 wires and then 1 single wire that goes off of there. So you'll be able to get a grounding one just by itself without having to clip a bunch of wires and put a bunch of tape on it. So that'll be nice and clean. Then we'll have one for the other side where the grounding isn't in it, but the plug's still there. So it's for the other side of it, for the AC, so that you can put it into your Variac. Yeah, I've been working on a lot of little stuff, man, trying to get these things just perfect. Because it really is annoying when you go to AC and it's not. And then the cool thing about that cat bank with that ZVS is you could put it in DC mode, get it to write the correct resonance, then automatically flip over and plug in your Variac and stuff, and then push all the AC through it. So, yeah, working on those, man. So that it's nice, clean, and beautiful setup because I get tired of capping things, taping them off, and it just looks junky. So I decided to take the time to build it out the right way. So working on those things, man, getting those going. I finished off a printer over here I got, and it's going to run I was going to run a 0.2 nozzle on it to do all of my geometry coils. Because what happens is when you start running these things, in each one of these lines, you have to sand them. And it has to do with the retraction speed of your printer. It'll leave little boogers on it, and I hate them. So what you have to actually do is slow that thing down a little bit, change that retraction timing, get this thing to clean up better on your printer. So I set up a printer just to print these things out. So what I'll do is I have that one. I'm going to run a limited run of maybe 3 and then put it on my shop, and that's it. And I learned how to do the epoxy on it, so it'll come out a lot cleaner than the one I have. So anybody that was interested in that, it'll probably be up here in the next 2 weeks or so, and I'll show it on the channel that I'm working on them. But yeah, I wanted to get those out there. Then we're doing the teardrops, the 2 of them like an hourglass, and we're going to get that coil going, and I want to make sure that one fires. And we'll do geometry just like Sean did. We'll do the pyramid coil. He sent me the STL files for the Death Star coil, the little bomb looking one, man. We'll go to that one and we'll do that. So yeah, I think it's totally awesome, man. We'll set that up and get that going. Yeah, it's really working out really well, to be honest with you, with a lot of this stuff. I got my garage halfway cleaned up. I just got rid of a lot of stuff. I was hanging on to a lot of stuff, thought, hey, maybe I'll use it. I get tired of tripping on things, man. Get tired of tripping on things. So I just started junking stuff. So hopefully it'll all be better, man. I'm almost done with the studio part on the other side. I got a little bit more painting to do. And then this, I'll take the R2D2 with me, like you guys said, but I'm flipping to the other side. So yeah, you can't wait to see the AC through it. Yeah. Oh, it's a monster. Let me just tell you that from preliminary runs, you know what I mean? Throwing in 40 volts to it on the AC, I can tell you right now it's already a monster. I wanted that primary to be perfect on there first, because I had the other one, it was on there and it was kind of touching in some spots and some it wasn't. And when you're running AC, you want that thing as close to perfect as you can. So that's why I was waiting for the STL before I cranked it all the way up. But that video is coming soon. You'll see it on the shorts on my channel. And I'm just going to blast the living daylights out of that thing. So if it goes up in smoke, at least you'll see it on video. You know what I mean? Not like we can't build another one. Yeah. Try it and find out. See why they always say that about my motto and things, because I fry the living daylights out of things if I have to. So yeah, that'd be cool, man. We'll get that going here soon. Almost there, guys. It's just taking a little time. One thing that I got to change over. I have my other channel for my podcasting, and it's going like crap. I'll be very honest with you. I completely failed at that. I'm not as controversial as everybody else, so it's not going to come out as good for everyone else. So what I'm just going to do over there is I'm just going to do geometry coils and rodent coils. So yeah, I'm just going to fix those 2 systems, man. I'm going to run every circuit that comes with them and just get those things done. I've been getting a lot of crap for, having them and not showing them and, letting other people do the work on them and stuff like that. So I'm just going to do it all myself. I'm going to start at square one. I'm going to order some wire, build some, print some out, get that thing going, man, and show every little part of it. I'm going to modify the living daylights out of some of these STL files and build the plastics. And then I'm going to wind coils, right, wrong, or indifferent. However the geometry comes out in my head, that's exactly how I'm going to wind it. I'm going to follow as many old school winding techniques as I can. I'm going to look for any geometry-based stuff out there, and then we're just going to go for it. And I got a circuit that's perfect for it. Thank you, Gerald. I appreciate that. And I'm just going to run that circuit on all of them. And we'll find out what we get. One way or the other. At this point, I'm just over it. And I'm just going to do that. I have a pattern I'm going to try first that I came up with, and I'm going to run that. And what I did was I printed out the bottom base to it. We're going to put the little sticks in there, okay? And then I got to wrap it. And I have another Tesla coil coming out. I've been working on it. It's well over 100 megahertz already. I thought I was losing my mind, to be honest with you, when I first built it. It's got an open core just like Tesla's. The primary is on the bottom, the secondary is on the top, and it literally is this big, okay? About this big around. And, I might have a picture of it for you. Let me see. It's very small. Let's see. There's the actual design of it right there. Primary on the bottom, open to everything. Small amount of wire on the top. This right here is already pushed back past my oscilloscope. So I have 100 megahertz available on my oscilloscope, and it will not register. Yeah, I put it on my ZVS circuit. It oscillates just fine. Put it on, static exciter. Will not show it on my oscilloscope. So my thought is very simple. My oscilloscope won't show the right reading, so I have to buy a new one. So I found one that's 330 megahertz, and I'm going to buy that one. And as soon as I have it, I'm going to test it again and find out exactly where that number is. So show you, let's see if I have, let me look real quick. See if I have the part that I printed out for it for you guys to take a look at. See if I put it in here. Nope. I'll have it somewhere on here. Of course, it's not where I could get to it. That's probably my downloads. There it is. There it is. That's the size of it. It is literally the size of a C battery. That's the size of it right there. And that's going to be the first coil that I put out that's an actual Tesla style coil. A lot of open air, just small winding on the top, couple windings on the bottom, and this thing blows through frequency like it's nothing. So, yeah, I have to upgrade my oscilloscope just to read this. I built one a little bit bigger just to verify that the oscillation is correct and everything else, if I can get it to lower the frequency. So, yeah, if I could do that, then we're good. Because these things are meant to run at very high frequencies, super high, like a couple hundred megahertz frequency like Tesla did. So, yeah, that's going to be a cool project, man. I already built a little one, way exceeded my expectations on it. So, get the other oscilloscope and I'll run it again, and then we should be good. If it outdoes that, man, I got to redesign, the size and everything of it. California blackout tonight, maybe. But yeah, and I want to build a bigger one, about like this. So the size of I don't know, like a pickling jar or a peanut butter. You know what I mean? Like a large size peanut butter can, about like this, about this. Yeah, I mean, something like that. I want to run that one too. And then we'll put the insulated wire, not the magnet wire, out there. Same thing, and it should work the same. And then we'll wrap it, and then I'll create, I don't know if I could do grooves on it, because last time I put the grooves in the small one, it was such small wire. They turned out like crap every time. But I think on this one I might put the grooves in there just so that it stays the same, and I can just glue each one of them with a little bit of super glue, or just the first and last part, and it should hold tight together. Maybe one in the middle, but there'll be high frequency, almost no amperage. We're talking 50 milliamps, maybe a little higher. That's it, and a super high frequency. So, yeah, that's what those will be there. So those are coming out too, man. I've been busy. Been working on a lot of stuff. So we also have the Society's High Science is setting us the circuit for the Tesla hairpin circuit. I'm working on that and working on the spark gaps. As soon as I get the spark gaps done, I got the coil already. That's all. The only thing I need to do is that. And I need to pull the two C-shapes to do the capacitors and spray them. That's it. That's all that's left on that thing, and I can have that one done too. So, yeah, I've been busy, man. Actually, took the weekend off. I took my granddaughter over to a little water area, little what do you call those? It's just a regular park we have in the area, and it was all water, man. She was in the greatest time of her life. She loves water, and she was like, as soon as we got there, she was full blast, man, running, bolting towards it, ran through every water thing, man. It was the funnest time. Yeah, she had a blast, man. We stayed there about an hour. It was real fun, man. Got to get away from everything this weekend, so that was really some good times, man. Uh, with a toroidal, hold on, do the testicles resonate with the toroidal coil? It depends on the frequency. So if you took all your toroidal coils together, all the ends of them, put them together, and took your oscilloscope on it, and what you're going to do is radio frequency method. You're going to scroll through until it pings a high frequency on your oscilloscope. So you put in a 10K ohm resistor, hook it in to the wires. You hook it to your oscilloscope, and you hook it to your frequency generator. And what you could do is just scroll through, and then when you get to the thing where it goes real high, that's the frequency for the entire coil. Now, it's going to be the entire coil because everything's wrapped together. And once you get that, then you could build a driving coil to match that, and it will turn on. So I figured that one out the hard way in doing some of this stuff. All you got to do is have a coil in resonance and then match that to the frequency of the coil you're trying to get it into, and they'll work. So it's a bit harder to pull off, and you better be good at doing frequencies to do it, but you can do it. I would suggest if you do it, you take your Tesla coil with a cap bank on it and build the cap bank to triple the size you normally would, so that you can scroll through a ton of frequencies on there without tearing all the wire off your Tesla coil. But that's how I would start to do it. As a matter of fact, I should probably run that for the other channel and do that so that people understand it. Well, it's supposed to be set up as two coils, the way that they have that thing wound, so that you'll be able to oscillate between the two. But the rodent coil isn't built that way. It's built as a Joule thief circuit. It's a coil in your Joule thief circuit. And as long as you remember that, you can get more energy out of it. That's why, because it's a coil in the Joule thief. Now, if you take the front and back end to it and put capacitance to it and get it equal to each other, then it'll eliminate some of the heat in the system as well, which would be really nice in order to pull the energy a bit more out of it. So, yeah, rodent coil is a whole different animal, man. They should have built it in two coils. I do not like that it's one. I absolutely don't like it. That's one of the things I'm going to modify on that thing, is making it two coils. Then we can start to play around, man. We can start taking one to the other and then making it pump two coils. I don't think a lot of people understand that about the geometry coil. You're doing that all over that thing. So what you're actually doing is you build a null point into it, okay? Is what you're getting in the center. And then all you're doing is you're doing like this with the capacitance to it. That's what you're doing. So what does that do? As you push it together, it squeezes it, and then as you pull it apart, it pulls more voltage out of it. And by running a south and a north in it, they go 1, 2, 1, 2. What you're doing is you're playing with that. You're taking that null point and going like this to it. And as soon as you do that to it, you're increasing the energy that comes out of it. If you know that, then that whole thing at 1500, different spots of that going like this is a gigantic amount of energy that comes out of it because that's what you're doing to it. You're compressing it. So it's like my gravity flyer when I compress that one right there. You've got a null point in it and you're compressing the null point. As you're compressing the null point, you're building energy. Think about it. Physics test, put the thing with a 9-volt battery together like this, pull it rapidly apart, you get 1,000 volts. Well, imagine doing that again and again and again and again. What happens? Any bubble that you build and then it fills it up really fast. Now it works on a different understanding. Yeah, you don't need to necessarily boost the resonance in it. You're taking advantage of what nature builds out. Anytime that you play with the center of your Tesla coil and put it to something, you can build a nodal zone in it real easy. But a geometry coil naturally builds it. And so does the rodent coil. It goes back to Bedini, what he said about how things work. When he told you to put in the negative energy, fills in the little round circles in your battery, okay? And it goes on the little plates that they put in there. It fills that in so it can no longer take the electron flow through it. What he's saying to you is it's creating that null zone in there with the energy that's combined between both of them that's interacting with each other that has the most energy possible. That's what he's creating inside the battery. So when you think about that, you put that into the center of your rodent coil, you'll be able to pull that same energy out of the center. What would be nice is to have the both sides of it, you know what I mean, so that it can increase the capacitance within it. That's why you build it out of 2 coils, not 1. Okay. There's an understanding there. And then, we can go freakish on it, man, and build coils that go like this so that we can increase the volume of energy going through it. A lot of people don't understand this as well. You'll change the temperature going on around you by playing with these and playing with that capacitance level like that. You're going to change the energy if you're doing it in a coil because you're pumping the stuff through there and you're either adding heat or adding cold to it depending on what you're doing. So it'll change the temperature going on. A lot of freaky stuff that you've heard about is going to start to happen. Yeah. Well, I want to say this. You always got to have a little bit constructive and deconstructive. And I want to say this. If you're dealing in anti-gravity, you want destructive. If you want to go and pull the energy out of the air, you're going to need constructive. You're going to need the flow, that the energy that's in the air. Got to remember, we're in a sea of energy here. You got to be able to pull it in. Build the orgonite coils. Yeah. Well, that could be on the list, man. Those seem fairly complicated, to be very honest with you. I've talked to Eighth about it several times, and they seem fairly complicated. It's not so much, I don't think, the design, it's the timing and how you got to do everything. Let's see. Let's see. Free energy oscillate between the positive and the negative. It depends what you call positive and negative. If you're in a closed system, in a DC system, then no. If you're in an open system where your high voltage potential is the top and the bottom is your magnetic field, yes. Yeah. Okay, we'll leave that one alone. I'll read it though. Nice. There you go. The timing. There you go. That seems like it takes a long time to put them together, and you got to put it in right. Yeah. I don't envy your job, man. I don't want it. Yeah, I can see by the layering, man. You put a lot into it. Yeah, way ahead of me on that. I just barely did. Um, you know what I mean? The resin on the outside. I couldn't imagine stacking them. Yeah, time it takes. Yeah, take forever. Nice, nice, man. I love to see it when you get it going, man. Just that sounds cool. Yeah, Joe says the future's now. So there you go. It's ours. Yeah, dude, it's gonna start to get crazy. So watch it for the other channel. I'm gonna start putting coil stuff on there, man, and just go for it. So every time I get something new in, man, we'll try it. We'll go through. We'll just do a regular jewel thief. We'll get a hold of Ben. We'll get him to. He's already sent me the diagram for his coil. I'll see if he's finished those things yet, and we'll run those. We'll have him on the show, and we'll talk about them. You know what I mean? We'll do our due diligence. We'll see who else has got coils, what they're doing with them, stuff like that. Just like we do on this channel, we'll do over there. Yeah. Starts with one step. Yeah, you know what? I agree with that. Clear some of the stuff off my plate first, and then we'll talk. Yeah. Will I show the new Cobra? Absolutely. Well, I'm going to record myself winding them, so you'll get all my lists and everything. I'm not going to hold back, man. I'm just going to let it out. So, and I'll do build videos on all of them. Do I provide STL files for videos? So if you go to Thingiverse right now, let's see if I can pull it up. I left them on there because I want everybody to be able to build that coil. All my ZVS and stuff is on my, oh, let's see. Sorry, give me just a minute. This thing taking forever to get through this. So share screen. You can see on there I have for my circuit. There's STL files in there for that. There's STL files in there for the Gravity Flyer. You asked about the Tesla coil. This right here is how you wind the number 1 coil. You wind it around here first so that you have the shape. You can use Old Man Build style right here, and it'll say that on there. So that's pretty cool. Or you can just get a blank one right here. Now it'll say 12.25. That's the inside diameter of the pipe that I use. So yours may be different. Just check it, because you may be modifying the STL itself on the inside. Because what I do in there is I make a pipe inside so that you can slide the pipe down onto it. So I can take super glue on the inside and glue it so that the two stay together. So yours may be a little bit smaller, maybe a little bit bigger. Just take your tape measure over there and check it. And that's in millimeters. So just take a ruler if you need to, and just go over to the pipe aisle, look for a 4-inch pipe and say, okay, what's the diameter of this? Make sure it's big enough. If you ever have to, you can always heat those things up with a heat gun and then, kind of pull it apart a little bit. That's a little more difficult. Easier just to find the right size pipe. 12.5 is the measurement. So that's the one it's based on. So hopefully that helps you out. That's most PVC pipes. So I've had one that's around 10 something, and it sucks when they do that, manufacturers. So hopefully that gives you the answer to your question. But those are there. Let's see. I'll go back to sharing that. Let's see what else I had on here. Yeah, I got all kinds of stuff on there. If you guys wanted to build the thruster like you would for a plasma channel or something like that, it's on there as well. So there's a lot of cool stuff, man, that I build LSTLs for. You go on there, check it out. Let me pull the link real quick. Go back. There's the that thing has beautiful plasma that goes through that thing, man. That thing is awesome. So you asked for the testicle. We'll just share that. And there you go, man. There's the link right there. I should actually do a video on that thruster, man, because that thing was pretty awesome. Oh, you got it printed, man? Did you get the package yet that I sent you? I was wondering about that. And then how did the STL turn out, man? You printed it, you said? Yeah, I forgot to tell you, man, I don't use any that fill-in stuff on those. You don't need it. It's all printed without it. I try to design everything that way. I hate putting infill in there. Yeah, I try to do that, dude. And then on my I came out nice. Very cool. Nice. Yeah, it looks like a barbecue grill. Yeah. Yeah, so some of the stuff too, man, I put it on my Shopify account in case anybody wanted to buy it out of the blue. For those of you who watch the channel, it's on Thingiverse. Okay. You'll be able to pick it up. I want you guys to be able to build this stuff and get it out there. But if you wanted my ZVS, STL, stuff like that for the fan, it's on Shopify. It's like $10, dude. It's not very much money. It just helps support me and what I do and be able to build things some more. You know what I mean? So that's it. It's there. All the understandings there. If you ever need anything as far as what parts to buy, I don't have any problem sending that to you. Just send me an email. So, yeah. Try to keep as many things open source as I can. You know what I mean? But a couple bucks is a couple bucks. I mean, it goes to wire. Spend a lot of money in wire, man. Sip it that way. I got probably like $1,000 worth of wire sitting over here. You see my desk, it's filled with it. Huh. It's quiet. I don't know what's quiet. I'll probably talk about this. Nice. Yeah, Darren, send some pictures in, man. I'd love to see them, man. Just shoot them to my email. That'd be awesome, man. I'd like to see that came out and which printer you got. Because I got old school CR10s, man. They work great for me. So I did want to get one of those oh man, I forget what they call it, one of those $1,000 jobs. It's all self-sealed up and it's got a bunch of different spools to it. I just haven't had the money to take care of that. But that would be really cool. But I like CR10s. They're easy to work on. They work great. Level them. Perfect use every time. Never had a problem. So, like I said, I did my other one. I'll show you real quick. We got some Raiders colors going on there, man. I did a standalone on it. So that little box you have to the side, I no longer have it. And it came out good, man. It just needs those little wheels on there swapped out. I got orange ones on there now. I want to get some silver or black ones. But no, it came out nice, man. Got a little Batman symbol on the side. Yeah, it's pretty clean. I like that thing. Oh, you got a monster one. Yeah, nice. I had some of those, like a Max. So, yeah, you can build anything you want on that thing, Darren. Heck yeah. Broke as well, yeah. Yeah, I got, I should probably publish those STL files too. I got all the files for that standalone thing, man, and it wasn't that hard to build. It just took a lot of time to go through it and put the exactly where you want the motherboard, exactly where you want things. I put in bigger fans into it. There's a lot of build plate stuff underneath it. Dude, it came out clean as heck. Oh, nice. Yeah, I think we're all kind of broke. Woo! Look at you go. Yeah. I don't want to tell you what I spent in printers over the last couple of years. Yeah. I actually picked up a set of scooter batteries, man. They were bad. And I got to see if I could do the Bedini thing on it. I think that's another thing I'll work on is putting the parts together for the Bedini motor, the schoolgirl circuit. I don't think that the circuitry is very hard. It's just and anything more than what we do here. As a matter of fact, it's less complicated than the geometry stuff. So give it a shot, man. See what's going on. See if I can revive those two batteries. And I'd love to do a pulse motor. So I know Papa Bill does those, and I already have the setup for it. I already built the little wheel thing to go with Mike's thing he was doing. And then Mike Faraday builds those things as well. He did his Renegade. So I think a pulse motor is going to be in my future, man. I don't know how far, but it's going to be there. So, dude, if you got a microwave, I hate to tell this to people, but there's some testing you could do with that thing that's pretty awesome. You kind of just find a spot in the middle of it where the compartment is and drill a hole in the back and stick up an old cell phone to it and tape it there. And let's just say when you microwave things, you can get a full camera view of it. You can get a nice shot that goes in there, man. Kind of neat and epic. I actually have a microwave on my list for my offer up that I want to pick up for like $10. Yeah, they may have cooked a lot of food in it, but it ain't ready for it all. Old man's gonna put it in there. I'm gonna make some plasma. So some guy, he had that on his channel, and then I put it on mine, and just like 2 seconds of it, and he got all butthurt about copyrights. You know what? Screw that guy. I'll just build him my goddamn self. So whatever. Huh. Yeah, I got a lot of things on the list, man. Now that I can walk around my garage, I can start doing them. Now that I got an inventory of stuff, start doing it. Hmm. Yeah, circuit's easy. The hard bit's the rotor and the frame. Well, if we're talking about the Bedini thing, it's just a aluminum rim or a plastic one. I'd like to get an aluminum one, and then it's basically out the magnets. This is a matter of math. That shouldn't be that hard. And then building the coil underneath it, and then we'll just take some wood. You know what I mean? That's all relatively easy. I didn't see anything overly complicated about it. It's like a weekend's worth of work to put it together. I mean, since you've never done it before. But yeah, I think that one's pretty good. Yeah, copyrights. Some of these people, man, are just so full of themselves. I don't care. I get it all the time. Hey, somebody borrowed some of your stuff. Have fun with it. Try to mention my name when you do it. That's all I care about. Mention my name so my channel grows so that we can get, more things going on. So we could do more projects. That's all I want to do. Do more projects, do more science. Oh yeah. Well, I do have a 3D printer channel. I just haven't used it in a while. And I should probably start doing it so I could show everybody how to build this stuff. Especially these geometry coils, man, since they're kind of trick. Yeah, I can show you a quick way to make them and how to figure out how to do everything in them makes your life a lot easier. I use Fusion 360 for all of it. So that might be worth a look to do that too. I really need someone in here to help me out, man, that's local, that knows a lot of this stuff like I do, so that they can start, you know what I mean, doing some of the stuff too. Maybe I'll find somebody. No, I haven't seen that one. Not a fan of the bike wheel. I could see that. Well, you could 3D print something. It's just not going to be as big. Well, unless you got Darren's printer, then you can build a bicycle wheel almost. Well, yeah, I mean, look, we could pull off some trick stuff on this, man. There's a lot of cool things we can do. Don't always have to work with the wrong stuff, man. Can always modify it, build it like he says to build it. We'll do that. Then we can start modifying, but not until. Got, you know what I mean? Get some good stuff, how he says. Skateboard wheel bearings, yes, I use those a lot. I have several stacks of them in the drawer over here. Use them for a lot of projects because they work really well. They really fine tune those things because skateboarders use them. So they're probably the best bearing there is. Looks like it could work. I'll have to check it out. I haven't seen it. Yeah, those bearings are the best, man. I'll tell you that right now. Well, because yeah, remember what the 70s they had the roller wheels that they used. You know what I mean? Remember the skate park you go to, and the roller rink, I should say. You go there, they had those kind of bearings in there. Then your skateboard had them in when you hit the half pipe. Dude, my buddy got a splinter in his butt when we were over on the half pipe as a kid. Funniest thing ever, man. I had to go over and get his mom pull it out. Dude, was hilarious. He asked me to do it. I go, heck no, dude, I ain't going near your butt. You know what I mean? You go get your mama to do that. This is hilarious, bro. Because we had the regular half pipe, so you get like a little 5-6 foot half pipe, and then you build the 12-foot one right next to it, right? So we had both, and then you do the side corner one. So at a 90-degree angle, you put another half pipe so you could jump the side. Okay, dude. At a young age, man, we were rolling down that thing, man. I had to learn to get into it. You know what I mean? To lean your weight and get down on it, man. Let me tell you something about those half pipes, man. You'll fall all over the place trying to learn that. Yeah, it's a weight distribution thing. You get up there and you better be prepared when you get to the other side because you're going to do a face plant. And you got to learn to be able to turn yourself, man. Hit that pipe that's on the top, man, and just take your trucks, man, and go right on it and grind that sucker, or just tail tap it at the top. Yeah, those are the good old days. Back when I was skinny and can do stuff. Man, I want to say thank you right now to Ulysses. Ulysses, you're so awesome, brother. 508 Man Build memberships, guys. Dude, the member section on the channel is awesome. I added stuff today. Sean gave a few more videos on there. I'm going to throw some of my RAV stuff on there. There's all kinds of things on electrics on there. So, dude, it's definitely worth checking out. Oh, yeah. Thank you very much, Ulysses, man. Taking care of me again, man. I appreciate it. Thank you very much. Nice. Right on, man. Yeah, that member sections, I'm trying to pump it up with a lot more stuff on there, man. So you love that. What does that say? He loves the Ashen, singled him out, and ripped him on his show. So you were happy to be noticed. It didn't matter if the ripping happened. That's right on, brother. Right on. Oh, get together. Yeah, we'll do another backstage, dude. That one was pretty epic. I mean, I'll tell you this: the one Joe and I did was pretty cool, man. We went into a lot of subjects, so there's a lot more out there too. Yeah, a lot more out there. Yeah, I got I was on Ken Wheeler's channel and I left a comment on there and I kind of said the same thing he did, and he gave me one of those weren't you listening, you dumbass kind of remarks back. I kind of laughed at myself because he was right and he had every right to do it. So I was kind of laughing though. So yeah, I know what you're saying, man. Said they were not ours and he flipped out and yeah. Ashton gets excited. That I have seen, man. Probably one of his best qualities. He gets excited, but not excited when it comes to, yelling at you or something like that. But if you loved it, man, I'm here for you, brother. Absolutely. Go for it, man. You gotta love that, man. Oh, you weren't nice to Joe either. Joe, Joe didn't learn the golden rule. You never talk crap on the anybody who's the host on the show, because then you get thrown out real quick. And Joe was over there trying to promote some stuff, man. And sure enough, he got it. I mean, I think everybody's okay with you saying your point, but when you start saying anything to the guy that's out there doing the work, you know what I mean? You're gonna get axed. You know, don't get me wrong. I'm the first one to screw around in the chat. I'll tell you that right now. I have no problem whatsoever just letting it loose. Some of my funnest times. Well, that gets a little excited. Hey, man, I get that way sometimes too. You don't think they're ours. I don't even know what you guys are talking about. Probably UFOs. Joe got timed out. Yeah, he did. Yes, he did. Yeah. Well, I think it's an opportunity for all of us to have a little fun. You know what I mean? I don't know if he bothered to got into the free, man. I'm just happy that he watched that day. You have the 2x2x1 boron block magnet. Okay. I'd love to see how that test comes out, man. Thanks for the juice. Oh, you guys are great. Yeah, I understand, man. I get on. I'm not above it. I get on there and I say what I want to say. You know what I mean in the chat. Yeah, I do it on everybody's channel, and then I'll make stupid jokes in there all day long, man. You'll know what I'm in there. You got a little stronger magnet than Ken has. Right on, man. I hope it works out for you. I hope you prove it right or prove it wrong, whatever you got to do. What's up, Crypto? Crypto had a journey, man. He actually got to the ocean. Right on, brother. Dude, the ocean's awesome in California, man. So, yeah, congrats on that, man. Got all the way back to Canada. Back to old Canada, man. Got to play in the US for a while. Oh. Ashton blocked you? Wow. Yeah, everybody's got something. Yeah, he didn't get mugged along the way. That's a good thing. He didn't get on New York subway. That's why. What'd you do? Oh, I'm sure everybody talks some crap sometimes here and there, and nobody can help it. Get it from every side. Wow. Yeah, dude, there was a guy in the chat earlier couldn't even spell English stuff. I don't know if that was on purpose or not. I was reading it as I was talking and going through stuff. I'm like, oh my god, dude. Huh. I got one guy. I got a troll on my channel, dude. So funny. He tried to troll me on Tesla calls, man. I'm sorry. You better be smarter than me if you're gonna troll me, brother. I had a good laugh. He tried to tell me that my Tesla coil wasn't a Tesla coil. He told me it was a Don Smith coil. Well, minus the 3 other coils you would need to make it a Don Smith coil, it could be, but it's a traditional Tesla coil as we know them, which is not really a Tesla coil, and that's what I told him. But I'll tell you what, you want to school me, you better do a better job. I found it absolutely hilarious. So funny, man. you got you got blacklisted too? You got a whole chat full of blacklisted people on the channel? Ah, yeah. Dude, Simple Man, I don't mind him, dude. That guy's fine. He can show up anytime he wants on my channel. I had to take him off when we did Mike's channel because Mike's no, it's his channel, and we're all streaming on his channel. If he says block somebody, I have to. I don't really have a choice, either that or get off. You know what I mean? So yeah, it's fine. Yeah, you can come back anytime he wants, man. He just talks stuff to just talk stuff to have fun in the chat. That's all he's doing. I don't think he ever meant anything by it. Some of the other people, man, though. Yeah. Yeah, I think Ken can back his stuff up. I want to see your test. I'm excited to see it. He doesn't go on other channels. No, he doesn't. That's a fact. Yeah. I don't see Ken doing that. No, but he's a smart guy, man. I watch the channel a lot. So I want to see the test. I just want to know how it comes out. Oh man. Yeah, man, it's gonna be an exciting time, man. Yeah, as soon as you do that test, man, put it up and I'll put it on the show. And we'll show it out. So Ken does a lot of so let's be honest about what Ken does. Ken shows you a magnet and he found this stuff. He uses this mouse juice, which is an oil, a little bit of blood, and he puts it in between 2 slivers of glass, and then he puts it on with a light. And what it does, it shows the magnetic fields of magnets, exactly how they build out. And he tells you all about how they work and everything else. And he's absolutely dead on right about how a magnet works. There's no question that he's got everything. He sees it. He was able to see the field of it, and he knows exactly how they're working. So, yeah, that Ken is awesome at that. I tend to agree with a lot of stuff that he says when it comes to the anode cathode relationship, how we work in the solar system, how things actually build out. A little bit of gravity difference, okay. But as far as how things build out with null zones, things like that, yeah, he's got quite a lot of good work on there for all of it. Okay. And the only time I would disagree is if I saw something different in the stuff that we're building and we see it differently, but not so much on a perspective basis that we don't know what's in it yet. So, but I'm sure he would change his mind if you showed him something different. So, yeah, there's a lot of cool things on there. Yeah, you'll have to check it out. It's worth the click on his video to watch that. That's for sure. If you want to see the magnetic field of a magnet and how it builds out actually, dude, best video ever. Go watch that one that Ken puts out. Nice. Yeah, crystals in water says crystals in water, you'd be surprised, man. There's a reaction that goes on there all the time. Well, that's just probably because, I'll be honest with you, probably because he gets tormented by a lot of people. A lot of people say, "Oh no, that's not possible. No, that this, this and that," and he probably gets a ton of it. I get a lot of it on my channel for other things that I do because people can't. Sometimes people can't figure out what I'm doing, and so they say it's impossible, or the video is cut at one spot and we move on to a different portion of it. They always say, "Oh man, it'd be nice, it'd be real if you would have left it alone." I get a lot of that, so I understand a little bit of that. But if you show him the test, I'm sure he would look at it. Hmm. Well, yeah, but I like to see the fields. If I could see the fields on what I'm working on, man, it'd be game over. It'd be game over. You couldn't tell me about imaginary things anymore. Couldn't tell me about imaginary parts that you think are in there in physics when they don't show up. So, yeah, hmm, yeah, that's what gets me, man. Some of these things, even God, even showing what they show is so awful. Like, I don't know how to say it. When they show string theory, guy, they take the string, they wrap it around, and they go, "Oh, it moves out like this, right?" What kind of moron puts that in 2D? Seriously. Like, am I the only one that thinks that's stupid? You look at it and you already know the guy doesn't understand what the hell he's talking about because it's a 3D model. You have to go to Blender and build something, man. You can't use off the shelf stuff. It's not the same thing. It gives you a misconception of what goes on. People think everything's in 2D. I swear to God, they think it's Tron 1. You know what I mean? Oh man, this is what we live in. And that's how they show everything, and it's awful. It's just awful, man. I can't stand it. As soon as I see it, it makes my stomach curl. Hmm. Yeah, they paid to have that model too. Yeah, they paid to make a little garbage. To be honest with you, my son models better that on Blender. There you go. Now we're talking. Model that the right way. Yeah. Yeah, watch the Math and Science channel. I just watched them yesterday, but they still do the same thing. By the way, Eighth, I did see that video you just sent me. I've seen that one already. As a matter of fact, they used that with some high voltage in order to make some kind of thing in the center like this um, of energy. It was pretty interesting because it lends through the magnets. So I did see that. Huh. Yeah, I wanted to build the same thing that he built, but they won't sell that mouse juice in my area because it's California. Stupid regulations get in my way. Yeah, nice. Your last documentary was good, man. I watched it. Joe watched it too, man. He says it was really good. So, yeah, that was good. Oh, really? I didn't know that. That was a remote viewer. I don't know what you guys are talking about in there, man, but it sounds interesting. Oh man. Yeah, so they've been tapping your walls too, huh? Wow. Yeah, that's some weird stuff happened to me, man, back a while ago. But they haven't done it since. So, but then again, I haven't worked on those projects yet since Tennessee. I put all those to the side. Yeah, man, it's gonna be fun. It's gonna be fun. We're gonna bet out some cool stuff, man, coming up. Got a lot of cool things in the work, man. Now I got some stuff to work out with it. I actually did the Sean Evo without the power supply, so that doesn't come in till the 8th of next month. So I'm gonna keep going with what I have, and I'm gonna change the frequency on that, man. And we should start seeing some cool developments out of it. Hopefully, we have an update here by Wednesday or Friday, and we're looking at that. We'll start looking at that one. We'll dust off the rodent coil and start doing some experiments on it, man. Last time I had it going, I had balanced both sides of it and the frequency. So we'll see how that goes again. There's something telling me, man, I'll be building another one. So I got to get some wire together. Another fun thing. What's going on, Time Energy, brother? You ever see his channel? You ever seen his channel, man? It's so awesome. He took my videos, man, and he put them in different languages. And I'm over there speaking a different language. I think it's absolutely amazing. But no, he's got some good work on there, man. I catch every English one that I can find. So right on, brother. Appreciate you. Nice. Get real about Raven course, like Bob said. Well, we'll see. We will see. Let's see. How do we do that? It's already got the energy in there. You just got to spark it. Would you use piezo discs on the outside in order to get the frequency into it? Um, just like Merkaba does to like put frequency into something, but these have to be attenuated to the outside or snapped to the outside or glued, whatever. Then you can put the frequency into them and see if it works. That might work. Dude, you could build like a little holder for it once you have the size of it and put two piezos in there, one on each side, and then just pull the thing out, turn it, and drop it back in. You know what I mean? Every time you want to use it and see what you can't come up with. That would be awesome. I think to get glowing and bright orange, though, you need to put in super low frequency. That thing has to be in the hertz, a low hertz. I remember that video. That thing was, you could time it, low hertz. Well, I don't think you have to move it so much. It's an anode and cathode relationship and frequency, man. If you already have the power in there, it's pretty easy. It's those piezos. You can make those do it. There you go, pressure waves. That's exactly what I'm talking about because the energy's already in there. It's already confined. All you got to do is, push the pressure wave, and do it in resonance like this. You might have it already. Maybe that's what he's talking about. Nice. Three feet across. Yeah. Oh, nice. Wrap it in copper wire as the head of the RAV. Okay. Well, if you got them, man, I don't have any crystals like that, or else I would do it right away. I know putting high voltage on the outside of quartz doesn't do anything. It doesn't penetrate it. You need to put the quartz in water or something else because you won't even get in there. You can do it in salt, but because it works in between the salt, but you can't do it in quartz. Yeah, if Joe hooks up and sends me some of that quartz, I'll test the living daylights out of it. Huh. The rabbit penetrating our dimension. Telling you, man, I don't see what's stopping us because of the way when you build this thing out, you start to learn how it works. So when we built it out, man, I learned a lot. Going through the first day, I learned a lot. When we're able to change the frequency and we can split the anode, we're in a lot more. I just want to get it down to where we can see it first, then we'll build a second one next to it. I don't see any problem in that. Just keep them far enough away they don't spark over. Got it right in the water, man. Right on. Yeah. You see what I'm saying? Then I'm right. The way that works. Quartz wrapped in copper. I've seen that a lot, man. I see that on Facebook a lot. Water hammer voltage. There you go. Yeah, some pressure. Oh, that might do it. That should do it. It does it for the pyramid. They will come. Nice. Yeah, that's cool, man. Yeah, we got a lot of cool stuff out there, man. You guys are doing great. Sometimes I think you guys are way ahead of me, man. You guys got a lot more stuff going on. Stuff I don't even know about yet. So more of a backup. Well, as soon as they slammed that water underneath it, man, and it started pumping like that to create that pressure, those that energy pushed through that thing. You know what? I do have a question, and I gotta ask Liz, and if you don't mind asking, asking everybody you talk to, Eighth, how tall were the Atlanteans? And I asked that because I was having an interesting conversation, man, with a gentleman yesterday, and we were talking about the height on Earth before the Great Flood. Was it a lot taller? And the Atlanteans would have been before that. So were they a lot taller? Were they like, you know what I mean? Really tall, where you may mistake them for the Anunnaki or whatever in the next century or something like that. Were they a race of giants, man? Like compared to regular people? I'm just kind of interested. I think we asked the question before, but I'd like to ask it again. So, yeah, because I mean, I don't think they were super tall, but like, 7 feet, 8 feet on average, something like that. I just kind of curious. Yeah, that's what I'm saying. If they were bigger, well, because I want to know how I say this. I want to know if the gravity changed on the Earth after whatever cataclysm happened to cause the next stage of evolution to happen, or next stage of whatever you want to say, where there was more gravity than there was probably back then. That's what I want to know. So, yeah, 6 or 7 feet would still be average too. Well, today it's getting to 6 to 7 feet, and we're getting close to the time of a reset. So that's what I'm looking for. If there was something more to that. Yeah, all my kids are like tall. Okay. Um, all my brother's kids are tall. So like 6'4", 6'5", you know what I mean? Something like that. And yeah, so 7, 8 feet's not out of the ballpark within, 300-400 years. I'm just wondering if there's something else going on here. Yeah, the gravity aspect, that's gonna be a big one, man, because I think honestly, when we look at it, And I think Atlantis was just the whole world. They see it as one spot. I'm not so sure about that. The three rings could be very simple. There's an ice ring, there's a ring that's nice and open air, and there's another ice ring that goes on the bottom. The three rings of Atlantis. And Atlantis is a whole planet. They wrote it in ancient Egyptian because the Egyptians appropriated their culture, and it's all over the world. That Egyptian writing is all over the world. And it was there for a lot longer than what we think. And all the pyramids, everything like that. So I think there's more to that. Let's see. There were a true power source both in the capacitors and generators. Yeah. Well, think about it. I mean, in the kind of war they would wage, it would be more than atomic bombs because if you have something that's pressing upon the planet like a pyramid and how it builds its energy, if you automatically turn 20 of them off at once, what happens? Then it affects the gravity on the planet because they're so massive in size. So that could have been, the start of the cataclysm there. If they got into a war with somebody and say that Atlantis was the entire world and there was a civilization that wanted to rule themselves, well, then you'd have a war, right? And that makes sense. And when they talk about Atlantean culture going to war, there's just ideas there. You know what I mean? And I'd love to ask again. We'll have to see. Yeah, because if you change the gravity on the planet, the water seeps up from the ground. If you don't know this, there's probably 3 to 4 times the ocean underneath the ocean inside rock. And if you mess with the gravity on the planet, you mess with the way it builds out in the spheres. You mess with a little bit of it, goes like this, boom, while that water rushes up, and we're all flooded. It feel like it came from everywhere, in every direction. Yeah. Well, yeah, those. I agree with you, man. The people over there at Harper ruining everything. Yeah, later called Amura. Yeah, that's what I'm saying. What if they were part of Atlantis and they wanted to break away? That's what it sounded to me. Hmm. Yeah, I think it was one big thing, and they wanted to pull away, and they paid a price for it. As a matter of fact, we all paid a price for it. Yeah, yeah, it might be different here a little bit. I'm worried about that thing coming through our solar system, so it's kind of big, and I want to see exactly where it went. Oh yeah, well, everything was interconnected. That's what happens when you have a single culture ruling the world. You build things that are built like that. You don't do different cultures building different things. You have one culture building everything. That's how it works. They map it out the same way. Then they go over to the people that are living in that area and they build it. So they may look different. We build different buildings all the time. So yeah, as long as it has the same function. It didn't rule anything except for themselves. Okay. Yeah, I think there's a ley line out here by me in over by Giant Rock. That's like what about an hour, maybe 2 hours from here. Yeah, I think there's one right over there. So you couldn't have ruled it wasn't in thinking. Well, see, that's the thing. We always hear about the people of it, not so much the leaders of it. And it's not about ruling when once it's all one thing. It's people wouldn't even understand the ruling part of it. You know what I mean? They would just be a culture of everything. They had to rule something. Tell you that even if it was just a small little country or something like that, they still had to rule it. So feel the energy. I don't know. I don't think that stuff works on a person like me. I'm sure Joe would feel the energy of giant rock. Probably I wouldn't. There are two different types of people, man. People are sensitive to energy. Some people are not. Some people are sensitive to magnetic fields. Some people are not. And sometimes it just depends on who you are and what's going on. Simple as that. Yeah. All those rocks, they cut like butter, man. They had specialized stuff for that stuff. Study him like she that she did say. You're absolutely right. You're right. All right, maybe I'm wrong. Wouldn't be the first time. That's so funny. Yeah, me too. All right, guys. It's been about 2 hours, man. It's been fun. We'll talk on Wednesday, man. Hopefully I'll have some more of my projects up and running by then. And we'll talk about some cool stuff. Sean's gonna be out this week for sure. He's resting at the lake house, man. But he's been on the Facebook with me talking about the RAVs and stuff. So pretty cool stuff, man. But with that said, man, I want to make sure everybody has a great day. And thank you very much for everything. And I want to say thank you to Ulysses, man, 50 Man Builds memberships. I hope everybody out there enjoys them. A lot of cool stuff on the members channel. Guys, I have a shop attached to my channel here now. And hopefully everything works on it. It's active. You can see it right under the video. They all should populate there. If it doesn't, let me know. But yeah, you can go on there and check out some cool stuff. If there's anything you want to request that I put on there that you saw that I build that maybe you want, just let me know. Other than that, man, have a great night.
The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.